All right, so you may have noticed in the last video, every single time we use one of these special right triangles, the setup looked like this, right? We were looking at the angle we were talking about in the unit circle. The hypotenuse was 1. The bottom distance here is always an x distance. This vertical distance is always a y distance. And so when we got up here, then we could write the ordered pair as x, y. Well, it also turns out we have some other trig stuff. So back in the day when you learned SOHCAHTOA, right, you learned that sine of theta is the opposite over the hypotenuse, and cosine theta is adjacent over the hypotenuse. Well, let's just take a quick look at this. In this unit circle, if I want to know the sine of this particular angle, the opposite, let's see if I can. Right, the opposite here would be y, and the hypotenuse would be 1. And so this could be y over 1. Well, y over 1 is just y. So what I'm learning is sine of theta is the same thing as y on the unit circle. Okay, if I do adjacent over hypotenuse, well, adjacent to this angle would be x, and the hypotenuse would be 1. So this is x over 1, but x divided by 1 is just x. And so what we just found out is cosine theta is the exact same thing as x on the unit circle. And so every single ordered pair in the unit circle is actually the value of cosine theta and then sine theta. Okay, or cosine at that particular angle and sine at that particular angle. It is important, obviously, which one comes first, and so I would bring to your attention that they're in alphabetical order, right? Cosine C becomes before sine or S in the alphabet, and so this is the order in the ordered pair, just like X and Y are in alphabetical order. Okay, so when I say using the unit circle to evaluate the 6 trig functions at a specified angle, well, we actually already know, right, that all of these ordered pairs that we just spent time developing in the previous videos, yikes, I already can evaluate cosine and sine really easily. I already know those, okay? So when I say something like, well, what's the sine at 2 pi over 3? Well, in my head, I need to think about where is 2 pi over 3? 2 pi over, here's 1 pi over 3, here's 2 pi over 3, and sine is the y value. Well, if I look, right, I know, first of all, I could use the left-hand trick to come up with what the ordered pairs here, 1/2 root 3 over 2, and so when I reflect it, negative 1/2 root 3 over 2, and since it's the y value, I know this is root 3 over 2, okay. Cosine of 11 pi over 6, well, that is almost 2 pi. Right, and so if I look over here, I'm thinking like, okay, it's that one right there. Well, I could use the reflection from this one in the first quadrant, right? It turns out that this is positive root 3 over 2, negative 1/2, okay? And so the cosine is the x value, and so this is also square root of 3 over 2, okay? Sine of 5 pi over 2, this is a value that's over 2 pi, right? Because 2 pi would be 4 pi over 2, and so I'm going to think about this as being equivalent to sine of 5 pi over 2 minus 4 pi over 2. It's like I'm going all the way around the circle, and so that means this is the same thing as sine of pi over 2, okay? Well, that means, right, if I look up here, sine of pi over 2, that's just the value right there, right? And it's the y value at that ordered pair, and that y value is 1. Okay. Cosine of 5 pi over 4, okay? That's a little bit over pi, right? Just a quarter past pi. And so let's see, I can do this one right here. I know this is, all the over 4s are great because the x and y coordinates are exactly the same. I just need to be careful of the signs. In that third quadrant, they're both negative, and so the x value there would be negative root 2 over 2. Okay. All right, so the idea is you don't want to be looking at a filled in unit circle every single time, right? You would do yourself better to kind of develop something like this for yourself where you can talk yourself through it. Okay, that's kind of the goal. All right, so we've covered 2 of the 6 trig functions, right? Which of the 2 do we know for sure? We know how to deal with cosine theta, and we know how to deal with sine theta. That's your x value in your ordered pair, and this is your y value. Well, what about the rest of them? Okay, in previous classes, I know you've talked about this, and if you don't remember this, this is something else that you got to get in your brain, right? There is a relationship between secant and cosine. Secant x is the same thing as 1 over cosine x. And likewise, cosecant x is the same thing as 1 over sine x. Well, here's the good news. If we already know stuff about sine and cosine, clearly we should be able to easily come up with cosecant and secant. Okay. Tangent, we know, is sine over cosine. Okay. And cotangent is just cosine over sine. Again, if those 2 things we can come up with, then we should be able to calculate those. And so as soon as you understand how to come up with these from the unit circle, you can do it for any of the 6 trig functions as long as you know these relationships. Okay, so using this information, how can we use the unit circle to evaluate any of these? Again, I'm not talking about pulling out your calculator and seeing, right? I'm talking about you actually doing the calculation. So let's talk about tangent of 2 pi over 3. We talked about where that angle was already on the previous slide. It's this one right here. Okay, it's the one where it's negative root 3 over 2 1/2. Again, you can get it from reflection of pi over 3 if you're not feeling comfortable with that. Okay, so we know from above this is the same thing as sine of 2 pi over 3 over cosine of 2 pi over 3. Okay, well, sine of 2 pi over 3 is the y coordinate at that angle. Okay, so if I take a, this is sad, right? I messed this up, so you shouldn't do that if you can possibly help it. Sorry. How about this? Negative 1/2 root 3 over 2. If you caught that, you can feel really good about yourself. Sorry. Okay, but I did catch it, so that's good. All right, so the y coordinate is root 3 over 2, and the x coordinate is negative 1/2. Okay, so technically that is true, but it's also disgusting because who wants a fraction in a fraction? So if you recall, one way to deal with that is instead of dividing by a fraction, you can multiply by its reciprocal. Okay, so if I multiply by the reciprocal of negative 1/2, I get this. And my 2's cancel. My final answer, negative root 3. Okay. Cosecant of 11 pi over 6, that's the same thing as 1 over sine of 11 pi over 6. Okay. We talked a little bit about where that angle was again, right? That's the one right here. Okay. And it's a reflection of pi over 6 if you kind of need some help. So that it would be root 3 over 2 negative 1/2. Check me. Okay, if I'm wrong, make the correction. And so this means it's 1 over, and again, sine would be my y coordinate, negative 1/2. Okay, again, that's 1 times the reciprocal, which would be negative 2. Okay, here's the secant one. Let's change up a color. So this is 1 over cosine of 5 pi over 2. Okay, 5 pi over 2, we talked about that angle previously, right? This would be the same thing as saying what's the cosine, 1 over the cosine at pi over 2. All right, well, pi over 2 is right here on my circle. I know this is the ordered pair 0, 1. Okay, and cosine is the x-coordinate. Now all of a sudden I have 1 over 0. This is undefined. Right, it is not okay to divide by 0. What this means is on the secant graph, there actually is an asymptote at 5 pi over 2, and also pi over 2 since they are equivalent angles. Okay. All right, last one, cotangent of 5 pi over 4. Same thing as cosine of 5 pi over 4 over sine of 5 pi over 4. So really all I need is what is the ordered pair at 5 pi over 4, and again, it's this one right here. In the third quadrant, both the x and y coordinates are negative, and so I'm going to have negative root 2 over 2 divided by negative root 2 over 2. Some of you can just realize same on the top and the bottom, and so you know what the answer is. If you're not sure, certainly you can talk yourself, instead of dividing by that fraction, multiplying by its reciprocal. And then you're going to see a lot of those cancellations happen for yourself, right? A negative times a negative is a positive. And so what are you actually left with? You're left with a positive 1. Okay. So you should be able to go ahead and evaluate any of those 6 trig functions at any of the angles given to you on the unit circle, or ones that are equivalent on the unit circle. Okay. All right, so again, this is the information you have in your brain. Once you have this, you are able to do a lot of mathematical things with this.